Right, so in this video we'll look at the hypothesis testing of a hypothesis which concerns the proportion of a population. So here we have a population that say it's the Danish population. We have, or maybe the health authorities have, a suspicion that 20% of that population is infected by some kind of virus. And that means 80% is not. So in order to see if that hypothesis is true or whether to believe in it or not, we would like to take a sample, a random sample from our population. And in this case, we choose 30 individuals that we will test. And it turns out that 5 of them are infected. Okay, so what can we say about this hypothesis? The null hypothesis is that the proportion, I'll call it P, is equal to some hypothesized proportion, which in this case is 0.2, 20%. Maybe the health authorities would like to convince the population, the public, that there's no more than 20% infected in the population. So this is the null hypothesis, but what should be the alternative hypothesis? Either it could be that the proportion is greater than P0, or it could be that the proportion is less than P0. So let's think about the scenario. Let's think about the case where we actually reject the null hypothesis. So are we to accept this alternative hypothesis or this? Which one should we choose to work with? If we choose the first one, we will only accept this hypothesis if the P sample, so the proportion in the sample, is significantly greater than P0. Significantly greater than P0. And if we choose the other alternative hypothesis, we will only accept this alternative hypothesis if the sample proportion is significantly less than the hypothesized value of 20%. So which one should we choose? Well, if we want to convince the public, if we want to make a strong argument, then we should go with this one. Because if we succeed in rejecting the null hypothesis, then we can say quite firmly and quite confidently that the proportion of infected people in the population is less than 20%. And that's kind of the conclusion we would like to make in order to calm the public and convince them that things are not as bad as they could be. But, and this alternative hypothesis would ensure that conclusion. That is, if we can reject the null hypothesis. On the other hand, if we reject the null hypothesis, we might conclude that the proportion is larger, but we will only conclude that if the sample turns out significantly larger than P0. So that's maybe not as reassuring, because we could have a sample which has a larger proportion than 20%, and still we wouldn't be able to reject the null hypothesis. So we might actually conclude that there's only 20%, even though there might be more. So if we want to stay on the safe side, this is the alternative hypothesis we should go with. Right. So how do we do the test? Well, as usual, we will have to compute a test statistic. And as usual, the test statistic is the sample result minus the hypothesized value divided by the standard deviation. And both of these come from the null hypothesis. This one comes from the sample. So the sample result was 5. So 5 people turned out to be infected. The number that we would expect according to the null hypothesis would be 20% of the 30 people. That is 6 individuals. How did I get that number? Well, 30 multiplied by 0.2. That's the expected number of infected individuals in a sample of 30. And the standard deviation, well, this is a binomial experiment. Either you get a success or a failure. And we know what the chance of success is. According to the null hypothesis, it's 20%. So the standard deviation of such an experiment, we know it from probability. It's the square root of the sample size multiplied by the chance of success multiplied by the chance of failure. Or in general, n times p times 1 minus p. So we put that into our test statistic. Or in general, x minus x naught, which is n times p, divided by the square root of n times p times 1 minus p. Now it turns out that this test statistic, which I'll call set naught, has approximately a standard normal deviation. That's why I call it set naught. But it's only approximately. Only approximately. In order to use this approximation, we should make sure that, and this is a rule of thumb, so it's not strict mathematics. We are approximating things here, so when is something a good approximation? That's hard to tell. But a rule of thumb tells us that n times p should be greater or equal to 5, and n times 1 minus p should also be greater or equal to 5. In our case, n times p is 30 times 0.2. That's 6, which is greater than 5, so that's all right. And for the other requirement here, we have 30 times 0.8, and that's 24. So both of these requirements are satisfied. So that means it's safe to use this standard normal distribution for this test statistic. If we plug in the numbers, we get a number like minus 0.46, and without actually doing the computation, if I draw the standard normal distribution here, we have 0 here, we have minus 1 here, we have 1 here, so to speak, and our test statistic is somewhere here. Now that means that this area here, since we're doing a left tail test, is our p-value. And as you can see, it's certainly greater than 5%. We haven't set the significance level yet, but if it is 5%, then it's pretty obvious that we cannot reject the null hypothesis. Since the p-value is quite a bit larger than 5%. So that means that this test is not able to conclude that the proportion of infected people is less than 20%. Even though the sample result was 5, which is less than 20% of 30, it's not significantly less. And that's why we cannot conclude that there's less than 20% of the population infected. Let's do this in Excel. So I'll make room for some explanation here. The sample size, well, that's 30. Let's call it n here. That's 30. And let's call it the sample result or proportion. That turned out to be 5. The hypothesis proportion, that's what I will call P0. That's 0.2, 20%. And the expected proportion from the null hypothesis, I'll call it x0. Well, that's 0.2 times the sample size. So we expected 6 people to be infected. In reality, there was only 5. Right. And then we can compute the standard deviation. I'll call it S here. And that's the square root. In Danish, that's this kvadratroot. Square root of n times p0 times 1 minus p0. There we have it. And now we can compute the test statistic. Call it z0. And that's just the result minus the expected divided by the standard deviation. So that's the test statistic. And the p-value is then, and we're doing a left tilt test, so we just need the normal distribution, the cumulative normal distribution. So I'll write norm. In Danish, that's normalfordeling. In English, it would be normal dist, I believe, something like that. And we choose the test statistic here. And it's a standard normal, so we'll plug in 0 and 1. And here you have to write true, or in Danish, sandt, to get the cumulative distribution. And as you can see, the p-value is way bigger than 5%, which I assume is our significance level. That means we cannot reject the null hypothesis.